Hello and welcome to this lecture. In this one, we would like to talk about load balancers inside the AWS console. So let's see what we can do with the load balancers. At the very beginning, I want to talk about the load balancing and what is load balancing and what is elastic load balancing inside AWS console. So elastic load balancing distributes incoming application or network traffic across multiple targets, such as EC2 instances, containers, and even IP addresses in multiple availability zones. And we know what are availability zones. Basically, they're different subnets. They're not in the same locations and they're a little bit far from each other. Elastic load balancing scales your load balancers as traffic to your application changes over time and can scale to the vast majority of workloads automatically, which is really a really good thing. Another thing that I would like to talk is what are the benefits of load balancing and having a load balancer inside AWS. So a load balancer distributes workloads across multiple compute resources such as virtual servers, and using a load balancer increases the availability and fault tolerance of your applications. You can add or remove compute resources from your load balancer as your needs change without distributing the overall flow of requests to your applications. You can configure health checks, which are used to monitor the health of the compute resources so that the load balancer can send requests only to the healthy ones. You can also offload the work of encryption and decryption to your load balancers so that your compute resources can focus on their main work. So if I want to basically tell you what is happening with the load balancer, okay, so let's have a blank page here. Imagine that this is actually internet. So internet. And you have your customers, your end users here. So these are your customers. And they want to access your website. If we have one EC2 instance here, imagine this is one of our EC2 instance. I'll call this one Web 01. Let's say this is just a Linux machine and we install HTTPD on this box. You remember this? We did this before. And this is now our web server. So one of the ways is just we spin up this one and we give it a public IP address, and our user or end users from the internet can directly hit this website and they can see our website easily. The next thing that we should think about it is, what if this web server goes down and something happened to this web server? If this web server goes down and something happened with this web server, then basically our end users can't see our website. And this is going to be a problem. So some people are saying, okay, let's have a solution. We can spin up another EC2 instance, another web server here. And now we know how we can take snapshots and basically make an image from it easily. So this is Web 02. And then our end users can hit the Web 02 easily and see our website. So which is okay, but there's a minor problem here. And the minor problem is that, let's say 50 million users, they were seeing our website from this Web 01, and 50 million are seeing our website from 02. So if Web 01 goes down, then half of our clients, they will notice that something is wrong with our web server. They will see connection timeout, and it's going to take some time for them to reconnect and reestablish their session to be able to connect to Web 2 and see our website. So this is not a good architecture actually. We should do this smoothly behind the scene. We should do this actually in a way that our clients doesn't understand that one of our web server goes down. So this is a problem. So what we can do in this scenario is, so we can basically do this. We can put something in the middle between our end users and our EC2 instance. We call it elastic load balancers inside the Amazon. And we tell our end users to talk to the ELB. So this is a load balancer, and we can put as much as web servers we want or any other applications behind the scene, behind this load balancer. Let's say this is our Web 01 until Web 10. Then in our ELB or elastic load balancer, we are just sending the traffic to these web servers behind the scene. If something goes wrong with our EC2 instances, then our ELB is going to check each of these web servers to see if they're alive or not. It's like checking these web servers all the time to see if they are working or not, if they are not working. And just validate if you are okay, if you are okay, and if you are okay. If some of them doesn't reply and we don't get any reply back, then our ELB is going to disable basically this node and is say, okay, I'm not sending any traffic to this one, but the rest of the web servers are alive, and I'm going to send the traffic to the rest of the web servers which we can show our website to the end user. At the end of the day, our end user, they will see that our website is up and running all the time, and they can start using it. So this is the idea behind the elastic load balancers or any kind of load balancers. We technically want to distribute traffics between different web servers. And in this case, if we have 100 million users, you can see that we don't have that much load on each of our web servers because we are distributing traffic among different nodes. Another thing that we can discuss here is that we can offload some of the features on the elastic load balancer. Let's say for the encryption and decryptions. We used to do this, all the encryption and decryptions on the EC2 instances and on the web servers. So this is gonna add more CPU utilization on your web server and you have to pay more. But with the elastic load balancer, we can offload this feature on the load balancer, and actually we can do the encryption and decryption on the ELB, on the load balancer, between the load balancer and the end user, and we're gonna save a lot of money. So this is gonna be a really good feature, and our EC2 instances will work smoothly and better with the better performance. So let's go back to our slides, and now we know about this load balancers and how they are working. I just want to tell you about the type of load balancers that we can use inside the AWS. And basically we have three types: application, network, and classic load balancers. The classic load balancers, the last one, this is the old one, it's going away soon in the AWS console, but we should be aware of it because it's still inside the AWS and we can use it. Basically on the application load balancers, we are using just for HTTP and HTTPS. It's a web load balancers for distributing traffics between different nodes. For the network load balancer, we can use for any TCP connections, and it also has the TLS for the encryption and decryption. And the classic one is supporting most of them. There's no TLS here, but it's SSL, but we can use both HTTP, HTTPS, and TCP on the classic load balancers. So let's go to the console and start configuring these load balancers. Okay, I am inside the AWS management console, and we'll go to the same location into compute and EC2. On the left side, we have the load balancing. If I click on the load balancers, I can see that there is nothing configured here, and I'm going to create a load balancer here right now, and we can test it with our web server, or we can spin up any other web servers we want into the EC2 instances on demand. So let's create a load balancer here. We have three options that we talked. These are the types of load balancers: application, network, and classic one. And you can see basically HTTP and HTTPS here, TCP and TLS here, and this is the classic one. And from the color, you can guess this is gonna go away pretty soon. The purpose of this demo, I'm going to use the application load balancer for now, and it's pretty easy. You can just click on create. In this menu, you can give it a name, and I call it app-elb-01 for our web server. And it is asking if it's an internal load balancer or it is internet facing. Well, because our web server should be available from the internet, this is gonna be internet facing. And now you can guess, you can even use load balancers internally inside your VPC environment, and you can load balance traffics and distribute it among different servers internally, even you don't need to have internet access, which is pretty good. And then you have to select if you want to use IPv4 or dual stack. I'll go with the IPv4, and what kind of traffic you want to do the load balancing. So it's HTTP or HTTPS, or web server would be HTTP, and you can add more listeners. This is your VPC. Right now we just have the default VPC, so I'm going to stick with this one. And this is the availability zone. You have to say, I want to use my load balancer in these availability zones, and I'm going to select all of them, which is pretty useful. Imagine if you can spin up 3 EC2 instances in each availability zone, even if something goes wrong with one of the AWS availability zone, let's say US West 2A, it goes completely down. Maybe there's a power outage or something, a disaster or something, then your website would be up and running and your end users won't notice because you put 3 EC2 instances behind the load balancer, and 2 of your web servers will serve data to your clients and they will not notice anything. Well, for now, I'm going to just select all of them. I want to participate all of these availability zones to my load balancer, and you can put tags, which is pretty useful. I give it a name, I put in my ELB. You can add more tags. For example, we can say env and dev, for example, or test, or whatever you like. So this is it for this configuration, step number 1. Step number 2 is configuring security settings. So I'm going to select next. In here, in the configuration settings, it just tell us your load balancer, it's not using any secure listener, and that's basically it. Is telling us that you're not using HTTPS, and we know this because our website doesn't work right now in the HTTPS. And I'm going to click next, and here in this step 3, it is asking us what kind of security groups you want to attach to your load balancer. And if you remember, we had a bunch of security groups before. Basically, we open HTTP and SSH. Here you can select any of those one if you like, but I'm going to create a new one as the purpose of this demo, and I just put it a load balancer wizard. One name here, and this one I'll leave them as default. And the port is HTTP, and it should be TCP on port 80 from anywhere. But I'm going to create this one specifically just for this purpose. And I'm going to click on next. So the next step is routing. We have to create something called target group, and basically the target group is going to send the traffic to our EC2 instance, which is behind our load balancer. So we have to select a new target group because we don't have anything right now. And I'm going to just give it a name, my target group, for example. And then what is our target? It could be one EC2 instance or multiple EC2 instances. It could be IP addresses, and it could be Lambda function. We talk more about Lambda, but it is basically a serverless environment. We don't have any compute. We can't access any compute, and we just put our code, and our code will run. Well, in our case right now, we just stick with the instance because we want to spin up web servers inside the AWS. The traffic is HTTP. The port is 80. We can even change the ports. And the health check is actually, we can tell our load balancer to check something on our web server to see if our website is up or not. I'm going to put a file in my website later, but here I have to define that file, and I define it as a health check because, so I'm going to put a file healthcheck.html, and we have to create this one actually later in our website to make sure that our load balancer can check this file, and if this file is available, and then the node is available too. If it cannot see this file, it means that the website should go down. And in the advanced settings, we are redirecting the traffic based on the port. You can override the port if you want. So we have a bunch of thresholds here. The first one is healthy threshold. This means, and you can hover your mouse on this eye, and you can see the settings and the help on this one. But basically, let's say if your health check shows that your website is down and it's not working, maybe this file is not available, and then this is the number of time that your load balancer will check if the file is available. Let's say the file is not available right now, and we are going to put the file back, and your load balancer check the file 5 times to make sure if the file is available. If the file is available after 5 times success, then your load balancer will consider that node as available. Another option here is unhealthy threshold. And this is the number of time that, let's say your website is up and running and something happened to this HCHTML file, and your load balancer check your file 2 times, and after 2 times, if it cannot see this file, or if there's something wrong with it, then it will put your node on an unhealthy state, and it's saying that your website is not working on that web server or EC2 instance. So the timeout is 5 seconds. So this is the amount of time in seconds during which no response means a failed health check, and so it's going to be 5 seconds, and then 30 seconds is the interval amount between health checks for an individual target. And the success code is 200, and if you're working with web servers, you should be familiar with this success code. It means that your web server is up and running. In a nutshell, let's say your web server is working fine, and suddenly this file become unavailable. Well, the way that the load balancer is working, it is going to check 2 times, and each time it's going to be 5 seconds because this is the timeout, right? Let's say it is going to check your file, it's not available, it waits for 5 seconds, it checks the file again, it's not available, it waits for 5 seconds, so 5 seconds, it's going to be 10 seconds. After 10 seconds, it's going to put your web server on unhealthy state. It means it's not going to work anymore. And then we have the interval here, right? This is going to be 30 seconds. It's going to wait for 30 seconds, and after that, it will try to check your EC2 instance to see how it works. And then if it's healthy, it is going to check 5 times to make sure that your EC2 instance is healthy, and after 5 times it's going to change the status of that EC2 instance to healthy and bring it up and running for your web service to the end users. So this is going to be too much for us, so I'm going to change this one to 3 and 2 and interval also 5. That's going to be faster when we are checking something. But we have to make sure that we are going to create this file for the purpose of this demo. So I'm going to click next here. Basically here we have to select our target. That's going to be your EC2 instance, which is behind our load balancer. Right now we have just one EC2 instance, and this is web server 01, and we can create as much as EC2 instance we want, and we can register them in this target. So let's select this one for the purpose of this demo for now, and click on next review. So this is our review, and I'm going to create our load balancer. So this is going to take some time, and it says successfully created our load balancer, and I can click on this one and I can go to my load balancer here. It's going to take some time because the state is still provisioning and we have to wait for this one to finish. So meanwhile, when we are waiting for this state, we can go to our EC2 instance and we can take a look at this one. Because we don't have our HTML file or health check file, then our web server won't be healthy inside the load balancer. So I'm going to connect to my web server here to create that file. This is the way that we can connect to our web server. And I'm going to open a terminal here. So let's give us some more room here. Paste this one and hit enter. So this is our web server. We are inside our web server right now. And if you remember, right now our website is just showing the default web page of an Apache. And we can test this one actually. I can copy this name or this IP address, which is here. This is the IP address, or I can copy this name. And I can go to my browser and I can browse it. And you can see this is the default web page. I'm going to change this one to make more sense for us and put a name here, for example, web01, and we are going to create that hc.html file in order to make the load balancer working. So because if I go to the load balancers, well, I can see that the load balancer is right now active, which is fine. But if you remember, we created a target for this load balancer, and here we have the target group, and inside the target group we have different options here, right? So for the target group, if we go to the targets tab, so interesting that there is no registered targets in my target, and I guess I missed that adding the target when I was creating my target. So this is a good way for the troubleshooting actually. So there's nothing, no EC2 instance in my target, and we'll check later, but I'm sure that during the creation of the load balancer we forgot to then click on add for adding our EC2 instance to the my target. We just hit next, which is a good thing. It is good for troubleshooting actually. So what I'm going to do here is that because there's no EC2 instance registered for this target, I'm going to hit edit here. And yeah, and we forgot actually to select. We basically, I guess now I can remember that I select this one and I hit next during the ELB creation, but we have to click on add to register to make sure that the target is using this one. So now it is using it. Click on save, then it's going to add this one. Yeah, now it is adding it, and the status is in initial state. So EC2 instance, it must have a ec.html file, and the ELB or load balancer should be able to see that file for passing the health check, and then our load balancer can use it, right? So let's connect to this web server, and we are here. I can run sudo su to go to the root. In here, so what I can do is actually I can go to var www, and we have a HTML directory. So remember this path. This is the location that we can put our HTML file, and then our web server can pick up that file, and we can see it actually when we are browsing our website. So I'm going to use vi and create one file called index.html here. I'm going to hit I here and put bunch of HTML tag codes here, and I'm closing it. And inside this one we can put, for example, body, and also we can close it. You can put whatever you like. You can put title for your website, but what I'm going to do is I am going to stick with h1 and just putting in headline and say web 01. This is our web server 01. And I'm going to hit escape and column right quit. WQ for right quit at the bottom of this page. You can see it and hit enter. So if I run ls now, we have a file index.html. This is gonna be our web server. Another file that I want to put here, that's gonna be hc.html. This is our health check. And I don't put anything in this one, doesn't really necessary. I just hit I and it's I put hc as an health check. And escape, column right quit. And what we can do is we can run systemctl restart httpd for make sure that our website is picking up these new files. And we can check, actually we can go back to this second tab and hit refresh, and I can see that web1 is available. And our HC file is also, it should be available. I can directly access to this one, and this one is also available. It's fine. So index.html or web server, it's going to show it by default, but other ones we have to access it directly if we have permission, actually. Fine, so now our web server is good. Let's go back to the load balancer to see how it is doing now. So I'm going to the load balancers, where our application load balancer, it seems it is active. And the way that we can access basically to our load balancer is through the DNS name. We don't have any public IP addresses for load balancers. And you have to be aware that the AWS is managing the load balancers itself. We can't have access to them. We can use them, but we can't manage them directly. So this one, we can just use the IP address, and it is internet facing. It should be we should be able to browse our web server behind the load balancer. So I'm going to copy this fqdn. This is the host name of the load balancer, and I'm going to check to see if we can see our web. Yeah, actually it is working now and it is successful. So I go back here and hit refresh, and it should be healthy. That's right. Right now this is healthy, and we can basically browse with our load balancer name, and we can see our web server. So if something happened with our health check, then our load balancer will disable this node, and we can do this actually. Right now it is working. I can hit refresh and I can see the website. It is fine, and you can see here it's healthy. I can refresh this one. It is working. I can go back to my Linux machine, and what I can do is I can basically remove that file hc.html. If I do this, then it means our health check shouldn't work anymore, and we should see an error here. So let's wait for a while to see what will happen. I'm going to refresh the page, and it says unhealthy. You can see also the error code here, 404. If I go back to the Linux machine and put the file back, I can create it with the same idea with the vi-hc-html. I can create it again, and I put hc here and write a quit. So the file is back here. So the health check should pass again after a while, and it's gonna be healthy. So I'm going to keep refresh this page here for a while to see what will happening. Let's hit the refresh again, and now it is healthy. So it's all depends on the health check. What I'm going to do right now, then I'm going to add another EC2 instance to this target, and I'm keep adding 3 EC2 instances in each availability zone to make sure that we have redundant web servers. So let's go back to the instances. For the purpose of this demo, I'm going to launch 2 more instances in other availability zones and put them behind the load balancer to make sure how it is working. So I'm going to select an AMI image and hit next. So if you remember, the first one is in the US West 2A, and we can double check actually this one. If I go back, if I cancel this one, I can see the web server that is up and running, and I can see that it's in US West 2A. We can see it from here clearly, and we can see it from here that the availability zone is US West 2A. So let's launch the second one using the first image. And I'll go with the default settings, but just the thing that we need to change is this one. This should be in US West 2B in another availability zone, because it doesn't make sense if you want to put it behind the load balancer. We put all of our instances in the same availability zone, because if one of them goes down, then we don't have any server in that availability zone. We should distribute our servers in multiple availability zones. So for the purpose of this demo, because I want to build a web server, I don't want to go inside the web server and run the commands. For doing this, I use the advanced details down here, and I can put actually the Linux commands as a script to run the web server and configure the web server. So what we need to put here is we have to tell the Linux machine that we want to run actually a bash script, and then the commands that we want to run inside the Linux machine. If you remember, we run the sudo yum update first for updating all the updates and security patches, and y we can put -y for the confirmation. Another thing that we can do is we can run sudo yum install. Basically, we can install the HTTPD web server, and then after this one we can basically run sudo echo for creating the index.html file and hc for the health check file for the load balancer. With the echo command, we are just saying to the terminal that we want to basically, for example, type this one inside the file, that the file is in var www.html, if you remember, and the name of the file is index.html. So we are creating an index.html file in this path, and we put this one as a content with the echo command. Doesn't really matter. If you remember in the previous one, we used HTML tags. Whatever you put into this file, the web server is going to show it to us. So it's not necessary to put the HTML tag. And I'm going to run the same command almost with the for the health check, and put it in the same location, www and html, and the name of the file now is hc.html. And then basically we have to use the systemctl to start the service httpd, and another command that we need to run is the enable, because we want to make sure that this service is up and running after the reboot. So I'm going to copy this one to make sure that we can use it also for the third web server. So everything looks good. Let's hit next to add the storage. So I'm going to select 8 GB by default, and then I'm going to add tags as a name, for example, and put this one as web -02, and hit next for the security group. And we can select existing security group. If you remember, we use ITrepo linux-sg, which is allowing HTTP on port 80 and SSH on port 22, which is fine for us right now for this test. This is just a review page, and if I hit launch, I can also select the SSH key for the authentication, which I'm going to use the same SSH key. And let's launch this one. So while this one is running, which we can go and take a look, this one is the one that is currently running. I'm going to give it a name for better view, and then I'll launch the third one, which this is gonna be pretty fast. Same idea, but in a different availability zone. It's gonna be 2C this time, and the advanced details, I'll put the user data, but I'm going to change this one just to web03, and hit add storage, going to the tags, put a tag here, and then the name is web03. Security group, it's gonna be the same security group for HTTP access mostly, and I hit next. This is the review, and I can use the same SSH key for the authentication. So right now, if I go back to the view instances, I have 3 EC2 instances that they are running, and I can actually use them for putting them behind the load balancer, and this is the third one that is in pending state. If you check the availability zones, so web01, which is this one, is in US West 2A, 02 is in US West 2B, and 03 is in US West 2C. So let's double check and make sure that these are up and running and they are working. So we are sure that web server 01 is up and running. We've actually checked directly from the web server, and actually it is behind the load balancer right now, and that one is working. So let's try web server 02. I'm going to copy the IP address, and let's close these ones and open a new tab and paste it here. So web 02 is working, and let's check the web 03, and here we can see web 03 is also working, and web 01, as we remember, it was working too. The font, it might be a little bit different because it has the headline. So web 01, these are in order: web 01, 02, and 3. They're all up and running. We can directly access to them. So now let's go to the load balancer. So if you remember from the load balancer, if I use the name here, DNS name of the load balancer, And if I paste it here, I can go to the web server 01, because just right now, just the web server 01 is inside the target. But we can go to the target group here and to the targets. Right now, this is just the web server 01, which is healthy. We can hit edit here and we can add other web servers also to this list. So instead of just having web server 01, now we can select other ones like web server 02 and web server 03, and we can add them to the target. So right now we have 3 EC2 instances behind the load balancer, and if they are all healthy, then we will balance the traffic, distribute the traffic between these 3 web servers, and if one of them goes down, then the user will go to other one. So usually my example is not a good one, because usually web servers, they have the same content, so end user won't notice that which server is serving the data behind the load balancer. But for the purpose of this demo, I put web 01, 02 and 03 as the content, so we should be able to see actually which web server is serving us when we are using the load balancer. So this is, for example, web 01. That's why my content is different, but in reality the contents are the same. So they are here. I click save here, and we have to wait for a little while to see what will happen to the status of these web servers down here. And you can see this says target registration in progress. So let's give it some time. Okay, let's come back. Let's hit refresh to see what will happen. And now they're all healthy, which is a good sign. It means that our load balancer can use all of these 3 web servers. So let's go back to the load balancer and copy the DNS name again here and try to see which website we can see actually. We are going to web server 01 again, and I hit refresh. I'll go to web 02, I hit refresh to web 01. So I keep doing this, and you can see we are actually going to different web server each time. This is kind of the this is the meaning of the load balancer, as you can see. So they're all serving the data are pretty fine, and this is the load balancer name that we can use. Now for the testing purpose, I go back to the EC2 instance, and I'm going to shut down the web server 01, and then we keep refreshing the pages to see what will happen. And as you can see, we are now just seeing web 02 and web 03, right? We are not seeing web 01 anymore. I keep going. I'm going to shut down web 02, and I keep going with the refresh. And as you can see, this is just web 03. And if I go back to the console, in the load balancer, in the target group, in the health check, we can see that 02 and 01, they're unused, and this is just 03 that is healthy. So going back to the console, and let's wait for these ones to go down. 01 is a stop. I'm going to right click on it and start it back. And 02 also, I'm going to start it back, but I have to wait actually because it is in a stopping state right now. So we need to give it some time. It is a stop now. I can right click on it and put it to a start state. So I actually bring them back. So let's go back to this one. It's gonna take some time because they should come back, and the status should change to healthy here. And you can see that 01 is actually unhealthy, is doing the health check. So we should be able to see them gradually. This is web 03. We'll just give it some time, and we keep refreshing here. And after a while, we should be able to see web 01, and this is it. Web 01 is now online, and this is a load balancing between a web 01 and web 03. So if we wait a little bit more time after the web 02 come up, then we should be able to see web 02. That's it. Right now, they're all healthy and they are all working. So that was it. Actually, in this section, I want to show you how the load balancer is working and how we can configure some EC2 instance settings with the user data. And I'm sure that now you are familiar with the load balancers, and it's a good thing. We need to use them if we want to have a high availability and we want to make sure that our services are up and running. This is the way that we can use it. So this one was basically the application load balancer. In the next section, I'm going to show you how we can use the network load balancer, which the idea is the same thing, but we just want to take a look at the settings and the menu. So if you are good, then let's go, and I'll see you in the next one.